Okay. So first we want to get, so I guess we might as well draw the picture. X, X, Y, and Y. Okay, along these here, Y, X, and X, the cost is $4, right? $4. And the cost along the top, the part next to the road, part next to the road is $10. Okay, so we first need to get an equation for the cost. So the cost is going to be, so let's see, we'll say the cost is going to be $4 times X, for that X there, plus $10 for that X, plus $4 times Y plus Y. So Y plus Y. Okay. So cost in terms of X is 4X plus 10X plus 4 times 2Y. So cost in terms of X, 4 plus 10, we got 14X plus 8Y. Now you can see there's a problem, right? We want the cost in terms of X, but here we have a Y. So we've got to eliminate that Y. And this is always the case with the optimization problems, is that you're given some extra information that allows you to solve for one of the variables and substitute it in. All right, so I have the problem here. And so you think to yourself, okay, what have we not used so far, right? We've used the price per foot, the $10, the $4, but we haven't used the fact that the minimum cost to enclose an area of, okay, so it wants to know what's the minimum cost to enclose an area of 2,500 square feet. That 2,500 square feet, the area of 2,500 square feet is what we haven't used. Okay, so the area of the rectangle there was 2,500 square feet. Okay, another way to write that area is xy. X times y, 2,500. And this is where we can solve for one of the variables and substitute it in. So y is equal to 2,500 over x. And now we can take that quantity and put it in there. Okay, so C of x, cost in terms of x, 14x plus 2,500 over x. Now we have our cost equation in terms of x. At first we had our cost equation in terms of x and y. Now we just don't have the technology, the sophistication to deal with that in Calc 1. In Calc 3 you can certainly deal with these things, with functions of two variables. But in this class, at this point, all we can deal with is one variable. So we have to use the extra information, put this information in there. Oh, and it was plus 8 times 2,500. There we go. That's what you're wondering, right? You're like, where did that 8 go? Exactly right. So we have an 8 there. Okay. All right, so let's simplify a little bit. Let's say C in terms of x is 14x plus, let's see, what's 2,500 times 8? So you got 0, 0, 5 times 8 is 40, 8 times 2 is 16, 17, 18, 19, 20. So 20,000. Let's see. Let me check my work. Let's see. I've got 8 times 0, 8 times 0. That one. 5 times 8 is 40. 16, 17, 18, 20, okay, 20,000. Okay, so 14x plus 20,000. Now I'm going to write this as 20,000 x to the negative 1 to set up to use the power rule. Because remember, to solve these, we take the derivative, set it to 0, and then use a sign, let's solve for x. When we find our x's, we use a sign chart to tell if it's a max or a min. And we want to minimize in this case. C of x is 14x plus 20,000 x to the negative 1. So we'll take the derivative, c prime of x. We're finding our critical points. Remember, critical points are potential maxes or mins. All right, so we've got 14 minus 20,000 x to the negative 1 minus 1, that's minus 2. Set it to 0. Okay. All right, so we're minus that, so let's move it all over here. So minus that, so we'll add this over here. So we'll have 20,000 over x squared equals 14. All right, we can, at this point you can use the cross multiply thing. You can think of this as 14 over 1, so that's going to give you, let's see, 20,000. X squared equal to that. Okay, solving for x squared. If x squared is equal to 20,000 divided by 14. Let's see, well, let's see, we could make this into a 10,000 and a 7. What's 10,000 divided by 7? Let me go get my calculator. Okay, so you've got 10,000 divided by 7. 1428.57. Okay. Squared 14 28.57. Okay. So x is equal to plus or minus square root there. Now we know. Now, you know, just to be sure, I might as well add on some extra decimal places so I don't mess up on the decimals. 429, there we go. Now, you'll see we get a negative answer there and a positive answer. The negative answer doesn't make sense, right? Because we don't want to have a negative length. All right, so take the square root there. All right, so x equals plus or minus, let's see, we've got 37.7964473. 7.7964473. All right. Okay. And so what did we just find? Okay. So let's see. So x equals 37.79644473. Okay. Remember, x is the length of a rectangle. right? So it's a dimension of a rectangle. Doesn't make sense for it to be negative, so we'll just take the positive one. Okay, so now we found x to be that guy. And now we need to find out, okay, is x actually a max or a min, right? We want, in this case, we want to minimize the cost. So does x actually minimize the cost? So let's make a little sign chart. 6. All right, so we might as well pick something easy to test. So let's pick a 1 over on this side to test. And over on this side, let's pick something easy to test. Let's say 40. Nice round number. Okay. You could pick anything to the right here, but you might as well pick something easy to test, so I pick a round number, 40. I could pick anything to the left to test, but I might as well pick something easy to test. 1 is one of the easier numbers to test. Okay. So remember, this was 20,000 over x squared. Okay, so now c prime of 1, and think about putting a 1 in there. That just says that's 14 minus 20,000. That's definitely a negative number. So negative, decreasing. Okay, now let's put a 40 in there. All right, c prime of 40. We can even see what this is. Okay, this is 14 minus 20,000 divided by 40 squared. All right. So let's see. 40 squared. All right, so let's just take 20,000 divided by 40 squared is 12.5. Okay. So this is 14 minus 12.5. Okay, you can see that's going to be a positive number. Okay, so c prime on this interval is positive. So we're increasing. Okay. So now, let's see. Decreasing to this guy here, 37.796, and increasing afterwards, you can see that that is a min. All right, we wanted to minimize, and we found a minimum. Okay, so the question now asks for the minimum cost. Right, so here is our cost equation in terms of x. And here we found that that 37.796 gives a min. So now we can go ahead and plug that in and find our minimum cost. Okay, so our minimum cost now, right, this is cost in terms of x. We know that this gives us a minimum cost, so C of 37.7964473 14 times this number plus 20,000 divided by this number. Okay, let's say 37.7964. That's certainly enough decimal digits to round to the nearest dollar. Okay. let's see, 14 times 37.7964 plus 20 divided by 37.7964 is 1058.3000524. Okay, now the problem asks to round to the nearest dollar. All right, so the answer is $1058. And that actually is the correct answer. So, cool.